All right. Well, hello, everybody. Thank you for coming out to this tech track. This is Safer Application Development with the OWASP Top 10. My name is Jonathan Singer. I'm with GuidePoint Security, and I'm our SIM and SOAR practice lead in the Southeast region. I've been in the industry for a little over a decade now, focused in cybersecurity, and I'm really excited to share some great information about application security with everyone today watching along. So to begin, I want to introduce this concept of the OWASP Top 10, maybe better known as the Open Web Application Security Project. Now, this OWASP, right, is a nonprofit foundation that works to improve security in software, and I mean really any software. The primary aim of OWASP is to educate everyone from maybe developers, designers, architects, managers, the organizations, that are most common going to be using important web applications, and we want to find those security weaknesses. Now, the top 10 specifically, part of OWASP as a whole, it provides the basic techniques to protect against these kinds of high-risk problems that you may run into. They are really good guidance and kind of steps on where to go from, as you're going through your application development lifecycle. Now, let's just go ahead and jump right in. The first of the top 10 is called injection. Now, every slide that I'm going to have here is going to have some great information on it. First, we want to talk about exploitability. In this case, injection is very easy. Next, we want to talk about the technical impact. And in this case, it's kind of high. So as far as the vulnerability goes, what's happening here with injection? Well, user-supplied data is not validated. It's not filtered. It's not sanitized by the application. Essentially, we're simply trusting whatever somebody tells us. Some of the more common injections that you may have heard of is something like SQL injection or OS command injection. Now, let's talk about how to prevent this kind of stuff. Preventing injection requires keeping data separate from those commands and queries. And what do we mean by separate? Well, using something like a safe API, the idea is that we want to segment out this dangerous code coming from our user, and we want to do what's called parameterize it and make it inert, no longer dangerous. Let's take a look at this example of an attack scenario. Now, an application allows untrusted data in the construction of a vulnerable SQL call or SQL call. What we're doing here is we're going to perform a selector, SQL call. But what's different about this is that we're allowing the user to send whatever data we want directly into the SQL query. In this case, we can modify, different parameters that are coming in from the user. And by using something like single quotes or double quotes, we can break out and start running additional SQL commands, something like drop tables. It becomes very dangerous very quickly, as you can see here, that adding additional commands is what's going to make our application vulnerable. On to the next. We have broken authentication. Now, this exploitability is also very easy, and the technical impact is high. When it comes to this particular vulnerability, what we're talking about is, having kind of authentication systems that really aren't up to today's standards. For instance, if your application simply just allows users to try different passwords over and over and over again, like a brute force attempt or an automated attack, that's not very good. Or what if your system allows users to have very vulnerable passwords, something like password one or admin or even default credentials? Another big thing is if your application doesn't support something of the form of multi-factor authentication in kind of today's standards. About prevention, let's think of it this way. You always want to use multi-factor authentication in today's standards. It's a great tool. In fact, it's all kind of plays on that concept of something you have, something you are, and something you know. You should definitely consider it, whether it's a soft token in your phone, a hard token, maybe a keychain, or any other type of factor. Something is better than just a simple weak password. You also simply don't want to use default credentials any opportunity you get. In our example, People can use a list of passwords that are very commonly found from cracked and hacked websites online, and it can be used against your application too, just to see if we can figure out if people are using popular passwords, which they do. Another example is that most authentication today make you kind of play this game of constantly changing your password, but it only works so much. People tend to be predictive, or we can start to guess what they're doing. So it's always good to try to use that multi-factor authentication when you get the opportunity. Let's jump into sensitive data exposure for number 3. This has a medium exploitability, but its technical impact is still high. Now, when we're talking about this particular vulnerability, we have to ask ourselves, is the data that we're storing and the data that we're transmitting within our application, is that secure? Is it something as simple as, is it being transmitted in plain text? Can anybody else over the Wi-Fi or the network see it, read it, analyze it, decode it, right? So you got to keep in mind of certain protocols such as HTTP, SMTP, and even FTP, still used today, surprisingly. Second off, if you're not encrypting all of that data, you also just want to make sure that we're using the proper security directives, right? Modern web browsers today have a ton of safety protections built in. There's no reason not to be using them. Now, when it comes to prevention, it's very simple. Let's just encrypt all the data. I'm just kidding. It's not that simple, but you get the idea. We want to make sure that we're using, encryption at every opportunity that we can, data at rest, data in motion, and we want to make sure that we're using modern encryption, so TLS, SSL, right out. And we also want to take advantage of all those security features, such as stuff like perfect forward secrecy, right? Cipher privatization, and secure parameters. We also want to make sure that we are classifying our data, right? Do we understand the data that we're storing that's being transmitted? And what are the requirements of that data? For instance, oftentimes certain compliance requires our data to be encrypted at rest and in transit. And so make sure that we're handling our data appropriately. Now, let's talk about this example attack scenario. A simple site does not use TLS. I know, it does still happen today. And that simply means that anybody who happens to be maybe on the same wireless network that can sniff that traffic, can see it in plain text, or any other, types of systems that could potentially be looking and peeping into the network traffic. There's no effort because it's not encrypted. Additionally, using passwords that are stored in databases that are not hashed. Again, if you're storing sensitive information, it should be encrypted. It just makes it a lot more difficult if it happens to get into the wrong hands. Let's move on to number 4. Now, this one's going to be interesting, so hang in there with me. Exploitability is a medium, and the technical impact is high, specifically for XML External Entities, or XXE. Now, this one is very specific, but focus with me here. Your application accepts XML, right, directly from the page or through an upload. But sadly, you want to make sure it's coming from a trusted source, not an untrusted source. Now, we saw that in injection. Untrusted users can be up to no good. Now, any part of your application that processes this XML, stuff like SOAP-based applications, or anything that has a DTD enabled, right? These are where this consideration comes in. So what do we do when we have a potentially vulnerable application, especially when it comes to XXE? Well, let's just try not to use XML when we get an opportunity. Maybe data formats like JSON. They're, in this case, less vulnerable. Additionally, you want to just make sure that you're patching all of your XML processors and libraries. This technique is very specific, but it works very well when it's in the right application. So if we take a look at this example scenario here, we see that an attacker attempts to extract data from the server by adding this entity tag. It's highlighted in red. And by using system, they can access a local file from the server, and it gets returned back to the user. Again, this is a little bit more specific to applications that utilize XML, but something to consider because of its depth of access on the system. Number 5. Broken access control. Exploitability is a medium, but the technical impact is a high. Now, this particular vulnerability, we access all kinds of different things in our system based on our user. But what happens when that logic doesn't work the way we think? What happens if a user can start to do things beyond what they're supposed to, beyond their privileges? So make sure that your access control enforces policies so that a user cannot act outside of their intended permissions, right? We want to make sure that they're not bypassing or stumbling upon functions that they shouldn't have access to. Simply because they're hidden doesn't mean they can't be used. And also, finally, elevation of privileges. Remember, a user that's logged in should stay a user. They have no need to be an admin unless they are supposed to be. So what do we do to prevent this? Well, you always use the simple concept of deny by default. This is the concept of least privilege, right? And we want to make sure that our access control mechanisms are following this rule. Additionally, you want to make sure that you're not trying to muddy the waters or make things complicated in the sense. Just use one access control method across your entire application. If you start to have disparate systems, you may leave a user with certain permissions on one end of the app, but elevated or different permissions on the other. So be careful with that. Now, in our example attack scenario, we are showing, again, something of that SQL injection that we saw from number 1. But what's different here is they're not necessarily affecting the SQL query. They're simply just changing a bit of information, maybe an account number on a bank. So we want to make sure that our access control shows that our user has actual access to a particular account number. That information is tied together and doesn't allow a user to simply see something else because they figured it out and stumbled upon it. Got you thinking now. Number 6, security misconfiguration. So the exploitability is very easy and the technical impact somewhat medium. This vulnerability, simple stuff here. Default accounts, default passwords, unchanged, unnecessary features enabled and installed. I'm missing just a lot of the standardized stuff. When you install a new system, are you doing your security procedure? Are you hardening it? Are you going through and changing all the default credentials? Are you not leaving it as default, right? Are you doing the proper steps? So how do we prevent this? Like I said, build a repeatable hardening process, something that can simply go through step by step when a new system is deployed or a new application is deployed. Make sure that security is actually applied, not simply turned on and let it go because it works. Remember, you want to keep it minimal. You don't need any sample features, components, all this extra bloat that comes with it. Get it all out of there because those individually could have problems. Let's take a look at our example scenario here, where an application comes with sample data or it comes with sample modules. Well, if these are simply forgotten about and those sample modules in time become vulnerable, well, that's an easy way in. So we want to make sure that anything that's extra and not necessary is tossed. So another example here is that your application is giving too much information. Have you ever stumbled on a web page where the error actually basically told you everything about the server? Well, that's really dangerous because that information can be used against you. So turn down that verbosity and make sure that whatever is public facing is proper and whatever is internal is important to you. Don't get those mixed up. As we move on to number 7, we'll talk about cross-site scripting. Personally, this is one of my favorites. So the exploitability, easy, but the technical impact is about medium. Now, there are 3 types of cross-site scripting. There's reflected, stored, and DOM-based XSS. In reflected, it's as simple as HTML being added to a page where another user views it. But it's, kind of a very directed, experiential thing. Now, stored XSS is if we can get raw HTML into something that's returned regularly to a page. For instance, like when a database is used to populate the content, maybe like in a forum, for instance, right? And then finally, DOM-based utilizes stuff like different frameworks that are more focused on the browser. Now, prevention. You got to use, some kind of method similar to injection where we're not just simply trusting the user data, especially what some people may think is not as dangerous, but HTML is actually really dangerous when it comes to stuff like JavaScript. So let's talk about our exact scenario where sadly they're not escaping the double quotes, single quotes, and all those other things that make, HTML inert. You want to strip that out when you get a chance. In this example, we're pulling in some, parameters from our user, untrusted again. But again, we're not necessarily sending it to a SQL query. We're just simply displaying this stuff on the page in our web application in HTML. But using JavaScript, we can collect certain bits of data like cookies right out of our browser and send that as part of a request to a remote system. Well, what can we do with a cookie? That's essentially your session in most cases. And if you can steal a user's cookie, you can assume their identity on that website and simply become logged in as them without ever having to know a username or password. So definitely keep this in mind. It's very easy to do, and it can have, I think, a very large impact. But it is very simple and one of the earliest kind of web attacks to consider. As we move into number 8, we'll talk about insecure deserialization. The exploitability is kind of more on the difficult side, and we'll get into why, but the technical impact can be devastating. Now, like XXE, where we saw with the XML-based applications, this is a little bit more specific, but in the right scenario, it definitely can be dangerous. So what is the vulnerability that's happening here? Well, objects and data structures may contain all kinds of information that is available to the user. We want to make sure that any of the application logic isn't simply just taking the user's word for it, right? Whatever is simply provided. And oftentimes data that's stored in a serialized manner can be used in all different kinds of functions behind the scenes. So think of it as somebody tampering with your application process. Now, when it comes to prevention, really, you want to just try to avoid accepting serialized objects from an untrusted source. You want to, if you need to use serialized data, you want to keep that to yourself. You don't want it to fall into the hands of the user. So let's take a look at what happens when it falls into the hands of a user. In our example attack scenario, we have this PHP form, for instance, that uses a PHP object serialization. And it's this, what seems like a useless arbitrary string of data. But what we see there is there's a field called user. Well, an attacker could potentially, and again, this is maybe stored in a cookie, an attacker could simply just maybe change user to admin and see how the application starts to respond. And again, this cookie is, in the hands of the user. It's untrusted, and it's brought back into our application. And now all of a sudden we can elevate our privileges. So again, you want to be careful what is brought into your application and make sure that it's coming from a trusted source. As we move on to number 9, we're talking about using components with known vulnerabilities. The exploitability is medium, and so is the technical impact. Now you may be asking yourself, really? Known vulnerabilities? Now hold on a minute. Let's talk about this. What is happening here? Well, oftentimes you may not know all the versions of the components that you're using. An application isn't just an application on its own. It's made up of a multitude of things: modules, plugins, add-ons, all kinds of things. And those all have their own, life cycles, versions, and tracking. For instance, there's also just software that's simply vulnerable that's still online. Are you installing old versions of things? Are you installing unsupported and out-of-date software? You'd be surprised it happens all the time for some weird arbitrary support really issue. And then finally, you're just simply not upgrading. I understand it's not as simple as saying go upgrade all the systems, but you do want to make sure that you're taking an approach that's risk-based and making sure that it's happening in a timely fashion. So how do we prevent this stuff? Well, there should be patch management, of course. You want to make sure that you understand what you need to patch, how you need to patch it, when you need to patch it, where you need to patch it, right? And we want to, again, remove all of those unused dependencies, unused features. We talked a little bit about this in a previous slide, where extra stuff that's bloat is not necessary, because that can inherently become vulnerable and hurt your application. Finally, you want to make sure that you're getting from official sources. There's a lot of places on the internet that may redistribute software that's been modified from the original source, and that's not going to do you any good. Maybe backdoored. So in our example attack scenario, one thing you want to keep in mind is that, a lot of these, extra components that come along with these programs, they run along with the same privileges as your application. So if your application is running as root or administrator, and one of these components has a vulnerability, it is going to have that same privilege to the system. So you want to make sure that things are, not running as a privileged manner. Second off, I highlight the CVE here for Struts2 RCE, but basically people continued to use this platform well after a vulnerability was discovered and posted online. Why? The research and the information is out there. You want to make sure that you're not putting your company at risk. Now we're finally moving on to number 10, insufficient logging and monitoring. Personally, my favorite, because this is what I happen to do with SIMs and centralized logging. Exploitability is medium and the technical impact is also medium. Now, let's talk about the vulnerability here. Are you able to audit your events? Do you know when logins, logoffs, failed logins, or other high-value transactions are taking place? Are you aware of this, right? Do you know when warnings and errors are being generated and they're not providing you with enough essential information for your team to act upon it? And then finally, what are you doing to monitor suspicious activity? Do you have systems in place? Let's talk about the prevention. We want to make sure that all access control, so login, log off, failed login, failed password, all that kinds of stuff is actually being logged, is being validated, and that there's enough information and enough context for you, the application owner and the security team, to be able to audit and review the actions that are happening. If you don't know something's happening then you basically don't see it, right? And we want to make sure that this data is in a format that's useful, that it's easily consumed, and it's centralized. So you want to consider using something like a SIM platform. Now, here's the example. Major company, right? They have this, system, and they are being actively attacked, and maybe some malware even makes its way in, and it's logged. The activity is there. The system knows that it's vulnerable. The data exists. But if nobody's actively looking at that information is not sending the right alarms and triggering the right systems, those logs may exist, and all that hard work is kind of useless because that information never made it into the hands of the right individuals. So don't just implement logging, you should make it functional too. Now that rounds out our OWASP top 10, and more information about this can be found at owasp.org. So I want to say thank you for tuning in, following along, hopefully learning something new. And again, my name is Jonathan Singer. I'm the SIM and SOAR practice lead at GuidePoint Security for the Southeast region, and you can contact me. Hopefully you're playing along in the chat or at the email as you see on screen, guidepointsecurity.com. And I'm also on Twitter using my full name, Jonathan Singer. So thank you very much, and have a good one.